When you're looking for critical values, there are two different ways of doing it. It depends on if you're using a Z chart or a T chart. When using the Z is when we're given sigma or population standard deviation. If we're not given this information, then we use a T. When we use the Z, what we do is we actually come here to table 9-1, and what this table does is it actually already gives us the critical values for a Z. So if we have a left-tailed test with alpha being 0.1, this is our critical value. If we have a two-tailed test, full alpha being 0.1, here is our critical value. You'll notice that the left and right-tailed tests have the same critical values, just different signs. That's because the graph is symmetric. Now the two-tailed test is different because remember what we're having to do is we're having to look up on our Z chart 0.05 here because we have to divide that alpha by 2, and that's how they get the positive and negative 1.645. Now, don't divide your alpha by 2 when you're looking for the critical value of a Z. This chart right here is only for a Z test when we're given sigma or the population standard deviation. Now, if we are looking at a T test, we're going to look at the T chart, and we have to find degrees of freedom, which recall is n-1. So let's say that our n is 15, our alpha is 0.05, and we're looking at a left-tailed test. So in this particular case, since my n is 15, my degrees of freedom is going to be one less than that, so that's 14. So what I do is on the T chart, this table A3, we're going to come down to 14. This is the row that we're going to stay on for the entire problem. We don't go back and forth to the Z when we're looking at a T. Now, since this is a left-tailed test, recall that when we graph it, it's going to be over here, which indicates that this is going to be a negative number. Now, on the T chart, it only gives us positive values. It gives us the absolute value of it. So whenever we look it up, we actually use the negative value. We just change it from a positive to a negative. Then I go to my alpha, 0.05, which is right here, and here is my critical value, 1.761. And it's going to be a negative because it's left-tailed. If it's right-tailed, we just use whatever is there. Now, let's look at what happens whenever we have a two-tailed test, okay? So let's look at a two-tailed test. So that is where our H1 mu is not equal to. And we have alpha being 0.05. We have n being, we'll say 17. So in this case, our degrees of freedom is going to be 16 because it's one less. Now when we draw our chart, and we shade in both sides because it's a two-tailed test, what that does is that divides my alpha by 2. So that divides it by 2, and divide by 2. So that actually only gives me 0.025. Let me write that a little bit clearer. Let's see here. So that's 0.025. is the value that is in here and in here. So I don't look up the whole 0.05 when it is a two-tailed test. Now my degrees of freedom is 16, so that's the row that I'm going to stay on for finding these critical values. And I'm going to go over to 0.025 right here. Watch how many zeros you have because you don't want to come over here. This one only has one zero in front of the 2. So this is my critical value. Now again, I have a left and a right tail, so it's going to be a negative 2.120, and a positive 2.120. So there's a difference in finding the critical values based on whether or not you have a two-tailed, a left-tailed, a right-tailed, or if you have a Z versus a T. So look over this, practice, and then let me know if you have any questions.